The James Webb Space Telescope at launch will be seeing forces as high as 20 Gs. That's 20 times greater than the force of gravity that you and I feel just walking around here on Earth. Making sure the various parts of the observatory, like this primary mirror segment behind me, will survive the stresses of launch is a big part of the testing going on here at Ball Aerospace in Boulder, Colorado. So Paul, these vibration tests, how long do you actually vibrate these mirrors?
Oh, it's really only for a few seconds at a time when we vibrate it, but we're mimicking the same loads that it will see while it's in the rocket, while it's launching.
Because the launch doesn't take a long time, right?
No, most of the vibration occurs early in the launch and then very soon will dissipate.
2, 1, 0.
We're about to hit full level sine sweep on this mirror.
What do you mean sine sweep?
What it does, it starts at very low frequency where you'll see the greatest displacement of the mirror. It'll move the most at the beginning, and then it'll get to higher frequencies. And as it gets to higher frequency, the mirror is moving faster, not moving as far at that point. And so you can actually see the mirror speed up as it goes through the sweep.
So is that kind of like what it will see during launch?
It will cover all the same range, the spectrum of forces, just like on launch.
So how do you know that the mirror passed?
We have 40 accelerometers mounted at different locations, different components on this mirror assembly. So each of those accelerometers is measuring essentially the forces that are being applied at every little component of the mirror. And we're continuously getting feedback from those while it's going through the vibration. By looking at all the different components, if one component were to fracture or experience strain or something, we'd be able to see a difference in the behavior of that component before and after the test.
Now I noticed it's in a plastic casing, kind of like it's in its own clean room, essentially.
And we're already inside a clean tent.
Yeah.
This plastic casing is really there for safety for us, just because the mirror itself is made of beryllium. If there were to be a fracture or damage to the mirror, that beryllium dust can be toxic. And so it's contained in such a way that if there were any kind of problem, at least we would be safe. But to date, we haven't had any such problem with these mirrors.
Well, thanks so much for giving us a closer look at the vibration testing that's going on here.
Oh, you're very welcome.
This vibration test is just one of the many ways engineers are making sure the James Webb Space Telescope is ready to go when it reaches its destination, 1 million miles from Earth. Thanks for joining us for this edition of Behind the Web.